Welcome to Code Math Academy. I hope your study is going well. So let's solve some more PYQs. As you know, earlier I have uploaded one video which contains 10 questions. So in that video also I have solved the PYQs and also explained each and every concept which is used in that PYQ. So same we will follow here. So first you should watch that earlier video, then you can watch. Okay, so let's get started with question number 11. And what type of code it will generate, we need to tell. There are four options: BCD code, gray code, 8421 code, and XS3 code. Okay, now we need to consider any decimal number in this. So I will take 13 as a decimal number. Okay, so what is the BCD code? BCD code, that is just we need to convert this 13 into 4-bit binary code. Okay. What will be 1101? Now see here, A, B, C, D. Okay, we will correspond this values. Okay, and then what will be the value of A? A will be 1, B will be 1, C will be 0, and D will be 1. Okay, now what will be the value of W? Value of W will be equal to A, because if you can say A directly comes here and the output will be A. So what will be the value? If we consider 13 as a decimal number, so W, which is equal to A, and A value is 1. Okay, now what about X? What is X? X is A XOR operation with B. Okay, now what is XOR operation? I will write here XOR truth table. So by referring this we will get the answer. Okay, 0 1 0 0 0 1 1 0 and 1 1. So 0 0 XOR will be 0 0 1 1 1 0 1. Okay, if both the elements are similar, then it is false. If both the elements are different, then it is true. Okay, so this is our truth table. So like this we are performing XOR operation. Now what will be the A XOR with B? Now see, what is the value of A? A value is 1. So 1 XOR value of B, B is also 1. So what will be the answer? 0. If we refer this table, 1 XOR 1, it gives us 0. So what is the value? I will write here value one by one. So W value is 1, X value is 0. Now what about Y? Value of Y, how we will get? B XOR with C. Value of B, B value is 1, C value is 0, right? So 1 XOR with 0, we get 1. So value of Y will be also 1. Then Z, C XOR with D. See, like this. From here C is coming, here D is coming. Okay. Now value of C 0 XOR with 1. Value is 1, right? So value of Z is also 1. Now what is BCD code? BCD code means whatever decimal number is there, that we convert it into binary. So what was that number? If we convert it into binary, that was 1101. But what we are getting? 1011, right? So option is not, so that answer is not matching. So BCD is not correct. Now let's see the gray code. What is gray code? What was our number? 13, which is wrote as 1101 in binary. Okay. Now how to find gray code of this binary number? To find the gray code, from the right hand side, that is from the least significant bit, we need to perform the XOR operation. How will we perform it? So take this 1, take this 0, perform XOR operation. what we will get? 1, right? Now again, take this 0, take this 1. From right to left we need to come by doing XOR operation. What answer we will get? 1, right? Now this one and this one, again XOR operation if we perform, we get 0, 1 1, 1 XOR with 1 we get 0, and whatever is the MSB, that is most significant bit, we need to directly write. So what is our answer? 1011, right? Now let's check whether we are getting 1011. So if you can see, we are getting 1011, right? So 1, okay, see 1011 we are getting. So our gray code is correct. So by this gray code, so whatever the circuit diagram is given, it is of gray code. Now what is this 8421? It is as similar as BCD code, right? It is as similar as BCD code, so it will drop. What is XS3 code? That is what we need to do. What we need to do is, in XS3 code, whatever decimal number we have considered, we need to add 3 in it. So what will it will become? 16. So we need to convert this 16 into binary. Then we need to check whether our given, so whether our given output is in that way or not. But if we take 16, it exceeds 4-bit binary. Okay, 4-bit binary is valid up to 15, right? So we need to consider the number which should be less than 15. So it is not logically possible because we have considered the number less than 15. Okay, but if we add 3, it exceeds the limit. So this answer is also not correct, XS3 code. So our 100% correct option is B, that is gray code. Okay, if you have any doubt, you can ask in comment section. I will answer. So let's move to the next question. That is question number 12. It is of TOC, right? Theory of computation. So what is the question? It is a simple straightforward question. A grammar is defined as, and this grammar is given to us, and they are asking the non-terminal alphabet of grammar is. Now what is non-terminal alphabets and terminal alphabets? So I will write here non-terminal alphabets. What are non-terminal alphabets? So these are the symbols, okay, which these are the symbols which can be further expanded, okay, and which can be further expanded or it can be replaced, okay. And what is terminal then? What is terminal alphabets? It cannot be expanded or replaced, okay. So if we see in this, in simple language, I will tell you that what are terminal and what are non-terminals, okay. See, all the alphabets which are capital letters, they are non-terminals, and whatever are the are of small letter, okay, these are terminals. This concept only you should know. If we see the options now, if we see in this grammar which are non-terminal, all of the alphabets which are capital letter, which are written in capital letter. So they are A, then B, then C, then D, then E. Only this much. So let's check the answer. A, B, C, D, E. Okay, right. B, C, D, E wrong, means partially correct, because if there should be there would be A, it would have matched with option number 1, right? So it is partially correct. A, B, C, D, E all, but X, Y, Z, these are terminals. So this is also wrong and this is also wrong. So just remember one concept. If the whatever alphabet you are given with, if it is capital letter, then it is non-terminal, and if it is small letter, then it is terminal. Simple concept. Okay. So let's move to the question number 13, which is from operating system. So the operating system and the other processes are protected from being modified by an already running process, because, so what does it says? That the operating system and other processes are protected for being modified. Okay, because when process is running, so there are some restrictions that it should not make changes in the operating system, in kernel level mode, in user level mode, and it should also not modify the processes, because if it does like this, then there will be then the operating system will throw the exception. It may get crash. Okay, so to avoid this crash problem, to uh, avoid this crashing problem, or what we can say, or to avoid these exceptions, there are some limitations which are given to the process, that it cannot access the operating systems and other processes. Okay, so we will see the options. They run at different time instances and not in parallel. Wrong. There is no any question. Okay, they are in different logical address. Partially correct. Okay, then they use a protection algorithm in a scheduler. No question of scheduling algorithms. So every address generated by the CPU is being checked against the relocation and limit parameters. Okay, so option number D is correct. Now why? I will tell you. So when the process is running, the operating system ensures that it cannot modify the OS memory. Then each process should remain within its allocated memory region. So whatever the memory is allocated by CPU or operating system, memory allocated to the process, it should be in that region only. Okay, it should be in that region only. So if it goes beyond that region, then exception occurs. Okay, now, so now how the memory protection is achieved? This is the big question, and question may be asked on this. Okay, so I will write here how memory protection is achieved. Okay, let's see. Now we have two registers, which is relocation and limit registers. Okay, limit parameter register we have, and relocation parameter we have. Now what is relocation? So in this relocation, it stores the physical address. Okay, in the relocation register, the physical address of the process is stored. Then what is limit parameter register? This stores the size of process memory. Okay, now everything is dependent on these two registers only. What is relocation register? It stores the physical address of process. Okay, process memory, whatever memory we have allocated, it stores its physical address. And what is limit register or limit parameter register? It stores the size, whatever size it has given for that process in the memory, it stores that. Okay, now this is this is all about now how it will check and how it will say it is valid or invalid address. Now, as we know, what is physical address? Physical address means relocation address or whatever stored in relocation register plus logical address. Now, now do you understand why I said that option B is partially correct? What is physical address? Relocation register, that is relocation address plus logical address. Logical address. Okay. Now, whatever. Now, every time process will generate some address. So, what will be operating system doing and CPU doing when the process is means what we can say, process is generating the address. Okay, then operating system, what operating system will do, it will check whether this address belongs to this range or not. If it belongs to that range, then it is valid generated address. Otherwise it is not. Okay, now how it will check? If generated address, now generated address is greater than or equal to relocation address, that is what is physical memory means, from where the memory has been started, that is relocation address. Okay, so if generated address is greater than that relocation address, then it will say okay, it is address, but one more condition it will say. This condition is not sufficient to ensure that this address generated by this process is valid. So second condition is, whatever the address is that, so whatever this generate, I will write it as GA, that is generated address, it should be less than, strictly less than relocation plus limit register. Okay, now what is this limit register? The size means it should belong to that range only. Generated address should belong to that range only. If it belongs to that range, then operating system ensures that it is the correct valid address. Okay, otherwise exception occurs. So in this way, the operating system checks whether the running process uh, whether the other operating system and other processes except running are protected and protected from the process which is running. Okay, now let's move to the question number 40. What is compaction refers to? A technique of overcoming internal fragmentation, a paging technique, a technique for overcoming external fragmentation, or a technique for compressing the data. Now, there are several new words. So first we will start from very basic again, as I told, fragmentation. What is fragmentation? Now, fragmentation happens when the memory is means allocated, when the memory is allocated or freed, that time dynamically fragmentation occurs. When memory is allocated, okay, or freed, that time this fragmentation occurs. Now, there are two types of fragmentations. So one is internal fragmentation and second one is external. Now, using the block diagram, I will be understanding you what is internal and external fragmentation. Okay, now what is internal fragmentation? Internal fragmentation. Now suppose this is one block, right? Its capacity is of 8 kilobytes. Now what I am doing is I will store the file in this of 6 KB. So whatever is this 2 KB, then this is the waste of space, right? Waste of space 2 KB. So this waste of space, this 2 KB is known as internal fragmentation. So what is the case then? How internal fragmentation occurs? Whatever other files we need to store, that size is greater than 2 kilobytes. So we are not able to store it here. So this space is void then. So this is waste of memory. Okay. Now what is external fragmentation? So now same example I will take. 6 KB is allocated, kilobytes is allocated. Okay, then there is one more block of 8 KB. In that 4 KB allocated, one more block of 8 KB. In this, let's say 5 KB allocated. Now if you can see here, 2 KB wasted, here 4 KB wasted, and here 3 KB wasted. Okay, now if there is file of 9 KB and I want to store it in memory blocks, okay, or suppose what we will be doing is we will be doing this as 10 KB, right? I will be doing this as 10 KB. So what, how much will be there? 5 KB. 5 plus 4, 9, 11. Okay, now if there is one 9 KB file which I need to store, if we see these memory blocks, now we cannot divide this file, and we will store 2 KB here, then 4 KB in second, in this first block we will be storing 2 KB, then in second block we will be storing 2 KB, 4 KB, and in this third block we will be storing the remaining file. This we cannot do because we cannot divide the file. So whatever we need to do, we need to store the file in a contiguous memory. Okay, that continuously it should show. Now if we see logically it is possible, because how much free space is there? 5 plus 4, 9, 9 plus 2, 11. 11 kilobytes memory free, memory is free, and our file is just of 9 KB. So logically it should store. So it cannot be stored because of this external fragmentation. This external fragmentation occurs. Due to this, it cannot store the 9 KB file. Now, to overcome this technique, to overcome this problem, we introduce new technique that is known as compaction. Now, what is this compaction means? Compaction means this technique is used to reduce the external fragmentation. Okay, so what it does, it shifts allocated memory blocks so that all free space is combined into one contiguous block. Okay, so what it will be doing, it will be shifting these blocks, okay, in such a way that all the blocks blocks efficiency is almost 100%, and whatever is the file uh, we need to add in that block, so accordingly the space should be empty. So what does the compaction means? It is a technique for overcoming external fragmentation. This is the technique, and what we will be doing is we will now, this is not logically possible example, so otherwise I would have shown you that we would have transferred these files. So okay, what we will be doing is we will be shifting this 4 KB in this byte, okay, then 5 KB here, then this 10 KB is empty, so that 10 KB will be allocated for this 9 KB file. So like this we will be doing. So this process is known as compaction. Okay, now let's move to the question number 15. In a linear hashing, if blocking factor, that which is BFR, loading factor I, and file buckets n are known, the number of records will be. We need to find the number of records for the blocking factors. So, what is blocking factor? Simple question. What is BFR? What is a blocking factor? It is number of records per block. Now, what is this block? This bucket is only the block. They have used new terminology as buckets, but it is nothing but the block, right? So, what is BFR? Number of records per block. Then what is I? I is loading factor. But what is loading factor? That is fraction of block capacity which is filled. How much in fraction block capacity filled. So how we can find that? It can be found using number of records. Okay, how much number of records are there, and total capacity. How much is the total capacity? Based on that we can find the loading factor. Okay, now what is BFR? That is number of records per block. So I will write here BFR equal to, how we can find number of records per block? That is from size of each block size upon record size. Okay, how much is the record and size of each record. Using this we can find the BFR, that is blocking factor. Now what is N? N is file buckets, that is blocks. So what does N means? Number of blocks. Okay, or we can say allocated blocks. Number of blocks or allocated blocks. Then see, now we have got blocking factor, then loading factor, then number of blocks. So now what we need to find? The total capacity. What will be the total capacity of file? So to find the total capacity of the file, okay, total capacity of the file using blocking factor into N, that is records. So what we will be getting? This much records it can store. Okay, total capacity, how much record it can store? Blocking factor into N, this much record total capacity can store, that is capacity. Total capacity is BFR into N records. Okay, so what we will be doing is we will substitute the value of total capacity and number of records. Okay, number of records in the loading factor. Okay, now number of records. What is number of records? Number of records is R. Okay, this is number of blocks. So number of records, we will initialize it with R. Here also they have given the number of records will be, that is R. R will be number of records. Okay, so if we substitute the value of total capacity in loading factor, what it will become? I equal to number of records is initialized with R. Okay, and what is a total capacity? BFR into N, right? And what we need to find? Number of records. So to find the number of records, what we will be doing is R is equals to shifting this to this side. It will go as multiplication. So I into BFR into N. This is the final correct answer. So let's match it with options. So I into BFR into N. So option number D is 100% correct. Okay. Now next problem is the post order traversal of binary tree is A C E D B H I G F. The pre-order traversal is. Now this question was means a little bit confusing. So now see, they have just given us post order. Now these are the tree traversal techniques, that is pre-order. Okay, I will write here pre-order, then post order, and in order. These are the tree traversal techniques. Why these techniques were introduced? Because we cannot means visualize the tree. So for that purpose, we have introduced this tree traversal techniques. Okay. What does pre-order means? That is, pre-order means first we need to write root. Okay. Then left side of root, then right side. Okay. For post order, first we need to write left, then right, then foot. For in order, left, then root, then right. Okay. Now, why I was saying this question was a bit confusing, because they have given you the binary tree. Okay, and they are asking for pre-order, and they have given just post order. Okay, so if binary tree, now what is difference between binary tree and binary search tree? Okay, if here it would be the binary search tree, then this question was valid, and we need to find the options accordingly. Then we need to construct the binary search tree, and then we need to proceed with the answer. Okay, now what is difference between binary tree and binary search tree? Okay, what does binary tree tells us? That the root should have two children, at most two children. Okay, root should have at most two children. What does the binary search tree tells us? That root should have at most two children, not at least, at most two children, but the left children's value should be less than root, and the value of right children should be greater than root. Is that right? No, sorry. This condition, it should satisfy to have a binary search tree. Now, in the given condition, for binary tree, they have given post order, but using just post order, we cannot find the pre-order, because we also need the in order. Because if we see the sequence using post order as they have given, we can recognize whatever the element is at last, it is the root node F. Okay, now to find the left children's and right children's of the root, we need the in order traversal. Okay, in order traversal we need. So from that we can distribute, so whatever the middle element is there, from that middle element we can distribute left and right, and recursively we need to perform the same operation. But as we have not given with the in order, if it would be case of binary search tree, then what is the in order of binary search tree? That is the ascending order is the in order. Okay, ascending order is directly in order. So if it would be the binary search tree, then we need to write a b c d in ascending order, and whatever will be in the middle, that will be the root node, and from that we would have distributed the left and right side. Okay, now in this condition, if it would be the binary search tree, then a b c d e f. Okay, e f g h I. So this is at f is a root node, so whatever these elements are there, this would be to the left hand side and this will be to the right hand side of f. But they have not given us the in order, because it is binary tree. For binary tree, it is not mandatory that left child should be less than or equal to root node, or right side child should be greater or less than. Okay, so the answer for this question is none of these, due to this reason, because the question is incomplete. If the in order is not given, we cannot proceed further. Okay, let's move to the 17th question. So it is what does the question says? 3 CPU bound tasks with execution time of 15, 12 and 5 unit respectively arrives at time 0, t, 8 respectively. If the operating system implements a shortest remaining time first scheduling algorithm, what should be the value of t to have 4 context switches? Ignore the context switches at time 0 and at the end. Okay, so what is a context switch? Context switch means the process which is running, we put that process to the hold state, and whatever the process is in the ready state, we it goes to the running state, right? So after all, what that process in hold state goes again in ready state, and the queue goes on. So what is shortest remaining time first scheduling algorithm? So it is a primitive algorithm. Okay, it is primitive algorithm. Now we need to draw the Gantt chart for this. Using the Gantt chart only, we can identify the value of t. So first we will be checking the value of t when it is 0. When t equal to 0, we will use directly shortest remaining time first scheduling algorithm. What does the algorithm says? Whatever means the process which has less execution time, it will run first. Okay, now it will execute first or run first. Now I will draw the Gantt chart for t equal to 0. Now at t equal to 0, process P1 comes. Okay, now at t equal to 0, process P1 also come, P2 also come. Both the process will come simultaneously. Okay, now as I said, what does the algorithm says? The process which has less execution time will run first. So accordingly, P2 will start running. So from 0, it will run till 8, because at 8 the new process or the new process arrives, which is one, which is that is P3, right? P3 arrives. Now what is the execution time of P3? It is P3 execution time is 5 units. Okay, time units. So but P2 has already executed for 8 units of time. Okay, it has already executed for 8 units of time. So 12 minus 8 So just so P2 is remain only 4 units. If we compare both, again P2 will start executing further because it has remained the less execution time. So till 12 it will run. Then when P2 execution is complete, then it will compare P1 and P3. Now obviously P3 has 5 units and P1 has 15 units, so P3 will start running. So till 5 units, that is till 17 units it will run, and afterwards P1 unit will start, P1 process will start running until 17 plus 15, that is 32 units it will run. So if we observe this, there is no question of context switching. Context switching is not happening. It is simple algorithm. FIFO algorithm is running. So this option is false. T equal to 0 is false. Now let's see. T should be less than or equal to 3. Now let's consider T equal to 3. If T is equal to 3, we will get the answer. Now for T equal to 3, what will happen? First P1 process will run because it arrives at time 0. So 0 to 3 it will run. Then P2 arrives. Now P1 and P2, both the execution time is 12. Okay, but as execution time is equal, so based on the arrival time, that is P1 has arrived first, so P1 will continue. P1 will continue. P1 will continue till 8. Okay, 3 to 5, 5. At 8, again, which one occurs? P3 occurs. P3 arrives. Okay. Now this P2 is pending. P1 has finished 8, so only 4 is remained. P1 is remained only 4. And what is P5? P3? P3 is 5 units. So again, P1 will continue execution and it will finish it at 15. Sorry, 8 plus 0 to 8, 8, 15. So sorry. Really sorry. No, sorry. So it will execute till 8, and what is the remaining time? That is 7 units, right? And then what is P3? P3 is 5 units. So as priority, so first context switch takes place here. Now P3 starts running. So P3 will start at 9, 9 to 14 it will run. Okay, then P3 executes. P3 executes. Now how much P1 is remain? Then P1 will start because it has 7 units and P2 has 12 units. So P1 will start. So from 14 to 21 it will run, and from 21 P2 will start till 33. Okay, 32, 33. So only once context switching is taking place. So this answer is also wrong. Okay, now let's see the third. Now as the condition is given 3 should be less than T, so we will consider T as T equal to 4. At T equal to 4 we will check. Okay, at T equal to 4 we need to check. I will write here T equal to 4, right? Again P1 arrives first. P1 start executing. So 0 to 4 it will execute. So how much it will be finished? It will be finished. P1 will be finished. It was 15, so it came to 11, right? So P2 arrives. P2 is at 12. So priority, priority also and less execution time. So P1 again start till 8. So minus 8, that will be 7. 7 is remain. P1 remain 7, but again P2 occurs. Okay, so sorry, P3 occurs because less execution time. So 8 to 13 it runs. Again after 13, P1 remaining 7, that is till 20 it will run, and after that P2 will run whatever is remaining from 20 to 32, right? Till 32 it will run. So now in this case also only once only context switching is taking place. So answer D is also wrong. Now there is we know this is only the correct answer, that is 0 to T, but I will show you how it is correct. So let's consider T equal to T equal to 2. Okay, now let's check here for T equal to T equal to 2. We will check. Now how we will check? Again P1 only occurs first, so 0 to 2 P1 runs. Then because P1 has run only 15 to 13, so till 13 only, so P2 first context switching takes place here, right? So from 2 P2 starts running, so from 2 to 8 it will run, that is for 6 unit time it will run. So P2 equal to 6, right? Remain. Now again context switching takes place because P3 has occurred and it has only 5, so P3 completes its execution. Okay, P3 completes its execution. I will drop this. Now here second context switch takes place. Now again after the P3 again context switch takes place and P2 starts running. So P2 will run till 19. Okay, then again context switch takes place and P1 will execute its work. So now if you can see 1, 2, 3 and 4. So 4 context switch takes place. So 100% correct answer is option number A. Okay, now let's move towards the next question, that is question number 18. Consider the following page reference string. So we are given with the page reference string. So what are the minimum number of frames required to get a single page fault for the above sequence, assuming LRU replacement strategy? So we need to have the we need to require to get a single page fault. Okay, only single page fault we need to get. So from 7 we will start. Okay, so what I will be doing is I will make the block of 7. 1, 2, 3, 4, 5, 6, 7. Okay, now I will putting the reference string. So 1, then 2, then 3, then 4. So all are this page fault. So okay, then again 2 page hit, 1 page hit, 1, then 5. Okay, then again 6, then again 2, second page hit, then again 1, second page hit, again 2, third page hit, then 3, first page hit for 3, then 7, okay, then 6, then a page hit, then for 3 again there is page hit, then for 2 again page hit is there, then for 1, for 2, and last for 6. So for 7 it is working efficiently, not we can say, we cannot say efficiently it is working, but let's see, it works for s number of frames. So let's try for 4. I will make here for 4, okay. So let's start from first, 1, 2, 3, 4, okay, then 2 page hit, 1 page hit, 5. So for 5 we need to replace the 5 with 3 because we are using LRU strategy, right? LRU strategy, that is least recently used, we need to remove, okay. Then we have replaced 3 with 5, okay. Then again 5, then 6. So what it was still single page fault, but now second page fault is happening. So for 4 it does not work. For 5 we will try, okay, 1, 2, 3, 4, again 1, 2, 3, 4, then 2 page hit, 1 page hit, and 5, then 6, 1, 2 page hit, then it will be replaced with again 3. So 6 will come here, again 2 is there, page hit, 1 is there, page hit, and again 2 is there, page hit, now 3. So second time we need, there is page fault. So for 5 also it will not work. Now let's try for 6. 1, 2, 3, 4, 5, 6. Okay. How much? 2, 3, 4, 5, 6, 7. So it is 7. So 1, 2, 3, 4. Okay. Now again 2 page hit, 1 page hit, 5 new element added, 6 new element added, 2, 1, 2, 2, 1, 2, again page hit, then 3 page hit, then 7. Now least recently used. What is the element which is least recently used? That is 4. So 4 will be replaced with 6. Okay. Sorry. 4 will be replaced with 7. Really sorry. 6 is already present. So 4 will be replaced with 7. So 6 page hit, then again 3 page hit, then for 2 page hit, then for 1 there is page hit, for 2 again there is page hit, and 3 page hit, and for the 6 again page hit. So using minimum number of frames required to get a single page fault for the above sequence assume LRU, so 100% correct answer is 6, because using 6 we can do it efficiently. Okay, so next question we will see. So 7 answer is also correct, but they have asked us the minimum number, so 6 is the correct answer. Let's move to the 19th question. The question is an aid to determine the deadlock occurrence. So these are the various types of graphs that we used. So resource allocation graph, which is also known as a RAG graph, that is RAG. We also see RAG graph. So first answer is only correct. Others are used for another work. Inversion graph, it is using means it is concept of discrete mathematics. Okay. Starvation graph, there is no graph. Okay. Question number 20. What is dispatch latency? Now, what is dispatch latency? Dispatch latency is the time taken. I'll write here, right? Dispatch latency. Dispatch latency is time taken by the OS to switch. Time taken by OS to switch the CPU from one process to another process. This is known as dispatch latency. So let's check the options. First option is the speed of dispatching a process from running state to ready state. This is preemption. Okay. Then the time of dispatching a process from running to ready and keeping it idle. This is hold state. Okay. Then the time taken to stop one process and start another process. This is dispatch latency. So option number C is correct. Okay. So dispatch latency. What is dispatch latency? It is time taken by the operating system to switch the CPU from one process to another. That is, we are giving the CPU from one process to another. Okay. So this is all about this video. So don't forget to like, share, subscribe. Okay. And share with your friends. So whoever are preparing for ISRO exam. Okay. Then good luck for you. Best of luck for your exam. Thank you. We will see some more PYQs in upcoming videos. Thank you.